Alright guys, so we are on 5E. So this section is about scatter plots and correlation. So the following scatter plots are sample data sets. Match each scatter plot with the best description below. Scales are omitted intentionally. So a scatter plot is basically a graph where each point in this graph corresponds to some x and y value, and we don't connect them like a line graph. We just put all these points, and essentially we're trying to see, well, what kind of shape do these points create? And here it says it is common to label the horizontal axis, which is this one right here, the x-axis, and then the vertical axis is what we call the y-axis. Our x-axis we can also consider our independent variable, and our y-axis will be our dependent variable. So let's take a look at some of these descriptions here and see, well, which one will match. So the first one says x represents the month number, and y represents the average temperature in Boston, Massachusetts. Boston has cold winters and hot summers. So here we're looking at this month. So the x is the month, and the y, which is the height, that is the average temperature. And so when we start off, it's going to be, x is 1, x is 2, x is 3, all the way to 12 for the 12 months. So if we look at, say, for example, the first graph right here, right, we see that, say, if this is when x is 1, so that's January, and our temperature is very low. Well, that could be true, because in January, in Boston, Massachusetts, you're going to have, cold weather. And so what this is saying is that the temperature always increases. So in January, it starts off as being very cold, and then it starts getting warmer and warmer and warmer and warmer and warmer until December, where it's the warmest. So would that make sense in temperature for Boston? No, right? Because temperature depends on the type of season. So in the winter months, we're going to have cold temperatures. Then it's going to get warmer in the spring. It's going to get even warmer in the summer. And then after the summer, it goes down again. So we're looking for a shape that starts off getting warmer and warmer and warmer from January. And then sometime in that middle time of the year, about summer, after that, it's going to start to decrease. And so if we look at our 4 scatter plots, the obvious answer would be D. Because here you see that in January, which is x is 1, you have a cold temperature, and then it starts to get warmer, still cold, but gets warmer, 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 until it's warmest. And then after summer, fall hits, and it's still warm, but it's a little bit colder than summer, a little bit colder, until we go down in December. So the scatter plot that matches with this description would be D. Now let's look at the next one. It says x represents the year in 5-year increments from 1995 to 2015, and y represents the Medicare expenditures in US dollars. And then here it says the increase is bigger every 5 years. So in other words, the amount that is being spent on Medicare is increasing every 5 years. And so if we look at our tables here, we know that it is a steady increase, right? So we know it can't be D because we've already used it. And if we look at C, we can see that it is actually a decrease, right? Each dot is a decrease. So really we're left with just A or B. And so what is the difference between these two scatter plots? Well, if we look at A, we have a pretty consistent increase, right? It's not too different in each part. Yeah, you may have, a little outlier, something that doesn't really conform to the rest of the graph, but overall we have a pretty steady increase. So we could say this is, this could model a linear function. Whereas if we look at B, you can see that here we don't have a steady increase. We have what's called a curve. And so we do have an increase, but as you can see, the increase is not the same. So from here to here, very little increase to go up. The same here, but then as you can see here, we start having a larger increase between the points. So this is what we call an exponential curve. So when we look at our question, X represents the year in 5-year increments, so every 5 years, and then the expenditure in dollar, the increase is bigger. Now, does it say the increase is the same at every 5-year period? No, it doesn't. All it tells us is that there is an increase, which means from 1955 to 1960, it could have increased, say, $100,000. From 1990 to 1995, it could have increased $1 million, right? So we don't really know the exact amount of increase, and it doesn't tell us that we have that constant increase either, which means it has to be an exponential function. And so that would be our B. All right, let's look at the next one. So here it says X represents the average outdoor temperature, and Y represents the cooling cost of the home. So think about this. What happens when the outdoor temperature increases? Is the cooling cost going to increase or it's going to decrease? It should increase, right? Because the hotter it is outside, the hotter it gets inside your house, which means your aircon has to work extra to cool down your house, which means your cost is going to be more. Your electricity bill will be more. So here, as our temperature increases, which is our X, our cooling cost also increases. And so here again, we have an increase, a line that shows an increase, which has to be A here. And so as you can see, you have a more consistent change here, but not very drastic. There's not a very big difference change between your months and the cooling costs. Yes, it does increase because you're going to, as the temperature gets hotter and hotter and hotter, the cost is going to be higher and higher and higher. So this would be a very good model for this situation. All right, so the last one means obviously it has to be C, but let's see why. So it says X represents the engine size and Y represents the city miles per gallon for a sample of cars. And then it gives us a little note that large engines usually get lower mileage. So here, let's start off with the first point. So what does this mean for X? This means that you have a small engine for X, right? Because X is the size of the engine, so small engines to large. And here we have small mileage to large mileage. So here it's saying that if your engine is small, you're going to have a high mileage. And here, if we look at the last points over here, it's saying that if you have a large engine, you're going to get a low mileage. And so that does definitely fit this description. All right, let's continue. All right, so here, it says scatter plots are a primary tool in statistics for examining two-variable numerical relationships. When you see a scatter plot, ask yourself the following. What are the two variables being measured? And what does each dot represent? As a researcher poses the following question for an observational study. Is there a connection between the typical marriage ages for men and those for women in the United States? Okay, so here's the research question. Now, the researcher records the median marriage age for men and the median marriage age for women from each state and Washington, D.C. The data are shown in the graph below. This graph is called a scatter plot. So again, right, a scatter plot is each each survey or each person that, in this case, you're talking about each state. So each state has its own dot. So we should see 51 dots, right, for the 50 states and Washington, D.C. So let's see what each answer will be. So A says, what does each dot in the scatter plot represent? So we could say each dot is a state or DC. What are the variables, right? So here we have to figure out what is our x variable, which remember is our horizontal axis. This is our x variable. And what is our y variable, which is our vertical axis. So let's see. Our x variable is the median age of marriage for women, and y will be the median age of marriage for men. And as you can see, the labels on the graph really tell you what the variables are going to be. Are these variables qualitative or quantitative? So if you recall, right, our quantitative variables measure a quantity, so an actual numerical amount, a number that actually means something. And so here, what do these numbers mean? These numbers are the age, right? So if I say 25, that has a specific meaning. It means 25 years old. And so here, the variables would be quantitative and not qualitative. Now D. The states in which typical ages for both men and women are the youngest are Idaho and Utah. Okay, so here we are looking at Idaho and Utah. These are the states that have the youngest ages for married men and women. The question here is, what is the typical age of marriage for women in these states? So here, we're looking at the youngest, so you're looking at these two right here. These two right here are Idaho and Utah. And it's asking you, what is the typical marriage age? Well, for women, right? Which means we're pretty much going down to the x-axis because that's where we're talking about women. So here, you know it's somewhere between 23 and 24 years of age. So we could say between 23 and 24 years old. Now it says, the state in which the typical ages for both men and women are oldest, Washington, D.C. So this right here, this would be Washington, D.C. What is the typical age of marriage for men in this state? So since we're dealing with men, we are looking across here. So if we were to more or less kind of guide it through there, we could see that the median age of marriage for men in Washington, D.C. is about 30 and a half years old. So we could say about 30.5 years old. And And if you think about why would that be, well, DC, right, there's a lot of professionals, a lot of lobbyists, a lot of, Congress men and women and stuff like that. And so typically, people who, study for a longer period of time or are more focused on their career are typically, right, on average, not every case, but on average, are going to get married later in life. All right, let's turn the page. So now we talk about what's called trends. So the trend of an association is the general tendency of the scatter plot as you scan from left to right. So we always read graphs from the left to the right, just like the way you read. And so trends that are increasing show a positive correlation between the two variables. So you can kind of think of the word correlation as like a relation, as a connection between these two variables. So they have a positive correlation between two variables if you read it from left to right, and it shows an increase. Trends that are decreasing show a negative correlation between the two variables. So a positive correlation means as one variable increases, the other variable also increases. And a negative correlation means that as one variable increases, the other variable decreases. So if we look at the first example here, right, what are the two variables? So let's see. Remember, this is our x-axis, this is our y-axis. So here we have grams of fat. Right, which we can label as our x variable. And a number of calories will be our y variable. What does each dot represent? So here, each dot represents a cereal brand. It says draw a trend line or curve to show the trend on the graph. And then it kind of tells you what should guide you when you're drawing this trend line. About half of the dots should be above the line or curve, and about half should be below it. So there's no perfect way to do this. You kind of just do your best. So I'm going to start about here, and let's draw something like that. So let's see. Below we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And above we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wow, so that's exactly in the middle, right? Half above, half below. You might not always get it to be that perfect if it's, not an even number of data points, but you just kind of do your best. So this right here would be our trend line. So then the question is, do we have a positive correlation? Is it increasing? Do we have a negative correlation? Is it decreasing? Or do we have no correlation, which means it's not increasing or decreasing? The dots are kind of just scattered everywhere. So there's no real way to show an increase or a decrease. So if you look at this, right, from left to right, we are increasing. So it is a positive correlation. A positive correlation between the amount of fat and the number of calories in cereal. And that makes perfect sense, right? Because the more fat content an item has, the more calories it's going to be. So now we will explain in context what this trend shows. So here we have to think. What goes here? So we know the two variables are going to go here. It says, as the blank increases, the blank would also increase. So which one is dependent on the other one, right? And so here, our grams of fat, that is going to determine how many calories. And so here we would have grams of fat. As the grams of fat increase, the number of calories tends to increase. Let's look at the next example. So here again, we want to identify what are our two variables. So remember again, this is our x variable, and this is our y variable. And so if we look at our first variable, we have the vehicle weight. In pounds. And then I'm just going to put here, this is our x. And then we have our mileage in miles per gallon, which will be our y variable. So what does each dot represent? So it says a scatter plot of mileage versus vehicle weight. So each of these dots represents a vehicle. And when we look at that specific dot, that's going to tell us, well, how much does the vehicle weigh and what is its average mileage. Now we draw a trend line or a curve. So here, I'm going to, again, try to draw it as best as I can. It may not be exact. That's not a problem. We just try to do our best. So maybe something like that. Doesn't have to be perfect, but more or less, right? Kind of try as best as you can to have half of the dots above and half of the dots below. So here, what happens when we read our graph from left to right? What happens? It decreases, exactly. So if it's decreasing, then that would be a negative correlation between the weight and the mileage of the vehicle. So what does this mean in our context, right? So typically in math problems, right, you think that there might not be a lot of writing, but in reality, most of the time you have to explain your answer. You should write your answer as a sentence to translate that math information to a context, right? So just to a statement that people can understand that kind of summarizes all your work and your information. And so here it says, as the blank increases, the blank tends to blank. So here we have to think about, well, we know what's happening here. It's decreasing, right? So we know that this is decrease. So as which one increases, does which one decrease? Well, as the vehicle weight increases, right? As it's getting heavier and heavier and heavier, what is happening to the mileage? It is decreasing. So as the vehicle weight increases, the mileage tends to decrease. All right, let's look at our last example. All right, so here we have a scatter plot that says scatter plot of age versus time. So here our x-axis, or our independent variable, is time in hours, and our y-axis, or our dependent variable, is age in years. So these are our two variables, time in hours, right? And that's important to put because time could be hours, days, minutes, seconds, years, decades. So that would be important to make a note. This is our x. And then our age in years will be our y variable. So it says each dot is a marathon runner. So here it is telling us specifically what this is because there's no clue in the title specifically on what we're talking about here. So each dot is a marathon runner. Draw a trend line. So here, think about it. If we were to draw a line that is going to have half the points above it and half the points below it, we will not be able to draw a diagonal line. Either way, it's not going to work. So the only way that we would more or less have to do it is by doing a line more or less in the middle. And as you can also see with all these data points, why is it more difficult for us to draw that trend line? Because they're not all going in the same direction. They're kind of scattered all over the place. And this is very indicative of a no correlation scatter plot, because we can't really say that one variable is affecting the other variable because there's no real line that we can draw. And as you can see, this is flat. So it's what we call, it doesn't have a slope. It's not positive, it's not negative. It's like a no slope. So we say there is no correlation between, and then what are the two variables here? The time and age of, who are we talking about here? Marathon runners. Now, think about it. Does that make sense? If a marathon runner, will the time and the age really have any kind of connection? And look at the age here. So you could say, oh yeah, sure, if the person's 80 years old, well yeah, they're probably going to run, slower than a person who's 40 or 35, etc. But if you look at this scatter plot, what age group are we looking at? We're looking at between 15 and 35. And so here, if you think about a 15-year-old versus a 35-year-old, if you've been training for this marathon, you're probably not going to have a huge difference here with the age. You have this big scatter of the time as well as the age. And so there is no correlation that we can point to using this information. Now, if we were to do a different survey with a different age group or even a different place where we got our data, maybe the scatter plot would look more close together, like maybe more linear, maybe positive or negative. So as far as this specific scatter plot of time versus age, we have to say there is no correlation. All right, let's turn the page. All right. This question 4 is talking now what we call strength. So we've talked about what does it mean to be a scatter plot. We've talked about correlation, positive, negative, and no correlation. And so now we talk about what's called strength. And so it says we will describe the correlation as, and so we have three things that we describe it as: weak, moderate, or strong. Based on looking at the scatter plot. The goal is to describe what we call the spread of the data points. So just like the word spread, right? If you're spreading your peanut butter on your sandwich, how that kind of spreads out in the graph. About the trend line or curve. So weaker correlations have a large amount of scatter above and below the trend line or curve. Stronger correlations will better fit the shape with less scatter above or below the trend line. Draw a trend line for each of the following linear scatter plots, right? So these are both linear because you can more or less create a line. Write a sentence comparing the strengths of the correlation between the women's heights and those of their brothers or mothers. So let's draw this scatter plot, trend line. So let's look at the first one, right? So this one is the woman's height versus brother's height. So this is the height of the brother, and then this is the height of the sister. So if we were to draw a trend line, right, something like that, more or less in the middle, about as much above as is below. As you can see here, there is a bit more scatter, right? The points are a little bit further apart. If you look at the women's height versus the mother's height, where the x-axis is the mother's height and the y-axis is the woman's height, you see that these are much closer together than they are here, making it a little bit easier to draw our trend line. All right, and then if we look at our two graphs here, right? This is the woman's height versus the brother's height, and this is the woman's height versus the mother's height. What could we say about the strengths of the correlation? So we could definitely say that there is a stronger correlation between a woman's height and her mother's height than the woman's height and the brother's height. So, of course, right, as always, data and graphs and studies, these are generalizations, which means they will not fit every case. But this is kind of generalized overall. So how could we write this? So we could say something like, there is a stronger correlation between the heights of women and their mothers than between the heights of women and their brothers. Looks like my pen just died, so let me get another one. All right, let's look at B. It says complete the description using the nutrition information scatter plot to the right. So here, right, we don't have it completely scattered around the whole thing. We do have it more or less in this kind of manner. So we could kind of draw a line. Maybe something like that, maybe a little bit lower, more or less. Remember, when you draw a trend line, it doesn't have to be perfect. You're just, doing your best. So if we were to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9. So yeah, this is a little bit unbalanced. Maybe a line like this would be a little bit better to kind of balance it out. But overall, okay. So what could we say? First of all, let's figure out what kind of correlation. So is this positive or negative? Well, when you read it from left to right, what's happening? It's going up. It's increasing, which means it's positive. And then is it going to be a weak, moderate, or strong? Well, look at the spread, right? These are pretty spread out according to the line. They're not nice and close, right? This we might say would be strong. This we might say is moderate. So this one would then be weak. Between, and then what are the two variables that we are considering in this graph? We are considering the grams of fat and the number of calories. For, what are we talking about here? Brands of cereal. Or just cereal. All right. Let's look at our last question. It says, possible explanations for correlation. The correlation may be a coincidence. Both variables might be directly influenced by some common underlying cause. One of the variables might actually be a direct cause of the other, although it may be only one of several causes. We typically graph the cause variable on the horizontal axis when this is the case. So remember, the horizontal axis, this is our x-axis. So really we have three main explanations for correlation. What we call a coincidence, so there's nothing going on between these two variables. It just so happened. There's underlying cause, so there's something that is influencing from one to the other, but we may have to like do a little bit of investigating to find this out. It's not like very obvious. And then a direct cause, which means this one actually causes the other one. So for example, smoking, cigarettes, that has been found, right, to cause a direct link to cancer. So that would be a correlation, right, that has a direct cause. This is not a coincidence. There's not an underlying cause. There is a direct link between these two things. So it says, for the scatter plots below, determine whether the correlation is likely due to be a coincidence, some common underlying cause, give an example of one, or one variable being a direct cause of the other variable. So let's look at this. So here we have our two variables. We have the size of a house compared to the price. So what do you think? Would that be a direct cause? In other words, does the price of a home depend on its size? Yes, absolutely, right? The bigger the house you have, the bigger square feet, the more it is going to cost. So this right here would be a direct cause. All right, relationship for the U.S. from 1999 to 2009, so a 10-year span. And here we have letters in winning word, and then we have people killed by venomous spiders. So do you think that the letters in winning words from spelling bees is going to have any relation between people killed by venomous spiders? No, right? But if you look at our graph, yeah, it does seem to kind of have like a weak correlation, a weak positive correlation, but this is clearly a coincidence because there is no connection between people getting killed by spiders and the letters in spelling bees that have won. So this would be our coincidence. All right, let's look at the last one. So here we have sample of cars for sale. So here we have the highway fuel efficiency, and then we have the fuel capacity in gallons. And so here we do see a negative correlation, a pretty close, so this could be moderate to strong correlation. So what do you guys think? Why is there that negative correlation between the fuel efficiency of a vehicle and the fuel capacity of the vehicle? Well, there's an underlying common cause. And what would that be? The vehicle size, right? That would be the underlying cause that is making these have that correlation. So we could say common, underlying cause. And then we could say what it is, what we believed it to be, which is the vehicle size. All right, and that is the end of 5E.